Okay, for the last topic on section 1.1, we'll look at symmetry of functions. So let's take a look at this example, example A. What you see is if you flip this function about the y-axis, so it's a reflection about the y-axis, so it's symmetric about the y-axis. If you flip the function, it remains the exact same function. So similarly here, if you take a function and rotate it by 180 degrees and function remains the same, the value remains the same, it's called symmetric about the origin. So we are looking at symmetry about the y-axis and symmetry about the origin. For a function to be symmetric about the y-axis, so what we need for the function is if you take f of negative x, it should be equal to f of x. So for example, if you look at 1, f of negative 1 here is this value, and f of 1 is exactly the same value. F of 2 is this value, and f of negative 3 is also exactly the same value. So f of negative x is same as f of x. So that's a function. It's called an even function, which is symmetric about the y-axis. On the other hand, if you rotate by 180 degrees, if it's symmetric about the origin, that means if you have a point xy on the function, then the point negative x and negative y should also be on the function, on the curve. So that essentially means that if you do f of negative x, that should be equal to negative of fx. Okay, so that is called an odd function, or a function that is symmetric about the origin. So basically what it means is if it is even, it's a mirror image about the y-axis, and if it is odd, let's take a look. So what it means is that f of x plus of f of negative x is equal to 0. That means if you look at the function, whatever is the value at x here of the function, and if you look at now negative x, f of negative x is negative of this value, so it needs to be here. So you're taking a mirror image about the y-axis and then mirror image about the x-axis, or in other words, rotate by 180 degrees and the function remains symmetric. So if function is even, if fx equals f negative x, and it is odd if f negative x equals negative fx. So as a very typical example of both kinds of functions, which you can easily remember, a cosine function, it goes like this. So cosine function, you can see, is an even function. So cosine x is an even function, and sine x is an odd function. And you can see because it goes like this. So at any x, it's so, and remember, sine of negative x is negative sine x, and cosine of negative x is cosine x. And that makes this function even and the sine function odd. Okay, and that essentially finishes this section of the chapter. The last thing is to see that the absolute value function, absolute value of x, which is like this, is an example of an even function. And here, one worked out example is looking at the absolute value of function and find its domain and range. Again, we have done problems on domain and range, so I will leave this as a personal exercise.